Wash your hands, men. Alright, polyatomic ions with transition metals. This is a little more complicated. Alright, let me erase what's on the table. We've said from the beginning that transition metals are weird because they have more than one oxidation number. That means they can become multiple ions. So, Roman numerals represent the charge of transition metals. For example, right here we have iron 2 phosphate. So that tells me that we have iron, and that iron, because of this Roman numeral, has a 2+ charge, just because there are 2 Roman numerals there. Okay, then I have to go back to my chart to find phosphate. Phosphate, PO4, 3-. PO4, and it has a 3- charge. Okay, you just cross them. We'll go with the white. Iron, then if we cross it, we'll bring down that 3. Then we have PO4. Remember, those have to stay together because if we change that 4, it is no longer phosphate and we need it to be phosphate. And we're going to bring down this 2. And that just means there are 2 sets of this polyatomic ion in that formula to keep it balanced. Okay, so let me work that out a little bit farther so you can understand it better. Fe3, PO4, 2. Alright, so we've already decided that iron has a 2+ charge because of the Roman numerals, and PO4 has a 3- charge. Alright, so if I multiply the charge of one iron by the number 3, because we have 3 irons in this formula, I will get 6+. Okay? Now I'm looking over here. If I multiply the 3- charge that is in one phosphate unit by this 2, I will get -6. And that equals 0, which is the goal, to get it to balance to 0. Alright, iron carbonate. This one is a little bit different, and you will see them like this. So iron, and then carbonate. Let's go up here. Carbonate is CO3 with a 2- charge. CO3 with a 2- charge. Alright, it didn't give us a Roman numeral. So anytime that happens, you just assume that it has the correct charge. So we're going to assume that it has a 2-. So if you were really actually writing this out, you should write iron 2 carbonate. But if you are not given this Roman numeral right here, you can still figure it out the way we just did. Alright, I want you to pause the video and try these 2. Please do that now. Pause. Alright, copper sulfate. Copper, I believe, is Cu. Let's double check. Cu, copper, yes. And sulfate is up here on our chart. SO4 with a 2-. SO4 with a 2-. And remember, we assume that this copper already has the correct charge, so that will be your formula. That is it. Alright, titanium 3 nitrate. Titanium 3 nitrate. titanium is right here, doesn't really help us much because the periodic table will not tell us the charge. We have to look for Roman numerals or clues. So we have Ti, and it tells us it has a 3+ charge. 3+. And then we have nitrate up here, nitrate NO3-. NO3-. And the minus just means -1. Okay, so we have to get this balanced out. You cross it over, and you'll have Ti1. We're just going to leave off that 1, and then you'll have NO3. And you still got to bring that 3 down here. And one last time, this has to stay together for it to be nitrate. We cannot change this number right here. Okay? Alright. I know this one's pretty tough, so let me know if you have any questions on the practice problems.